Hey everybody, welcome back today. 11.3 arcs and central angles will be coming your way. Okay, we're going to be learning about different properties today. Properties are going to be dealing with arcs of circles. So the very first thing you have to figure out is what in the world is an arc and what in the world is a central angle. I have these. Please write all of this down. And we will discuss in just a moment. All right, so a minor arc, there are different arcs inside a circle. There are minor arcs and there are major arcs. A minor arc is an arc whose midpoints are on or in the interior of a central angle. So if you look at the arc of AC, okay, because it is the arc of AC, okay, that's a minor arc. We are looking for, if you look at that, we are looking for that red line there, okay, and that's going to be the exact same as your inside arc. Now, or the inside central angle. Central angle meaning inside. A major arc is an arc whose midpoints are on the exterior of a central angle. Okay, so again, if you look at X, that is your central angle. Okay, remember our central angles have the exact same measure as our minor arcs. If you would take 360 and subtract your minor arc of ABC or AC there, we would be finding a DC. Okay, so we would subtract from 360 because there's 360 degrees in a circle. Last but not least, there are something called a semicircle. If the endpoints of an arc lie on a diameter, the arc is a semicircle. Okay, basically cuts that circle in half. Okay, and we know that semicircles are 180 degrees. All right, let's get to some calculation stuff. All right, in just a second, of course. Okay, basically, the measure of a minor arc, when you figure this out, you are measuring the central angle. The measure of a major arc is the difference of 360 degrees and the measure of the related minor arc. So I do want you to know that, and please write that down, even though you have written a little bit of it down. Okay? All right. So the measure of an arc, again, there's a little bit of writing here today. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if you look at this, just like our addition angle postulate, we talked about addition segment postulate, we have the addition arc postulate or arc addition postulate. If I have AB and I have A or BC, that is going to equal all of AC. Okay, so just add those two up and they equal ABC. Okie dokie, okie dokie. All right, so we're going to do a few things with arcs right now. Okay, you do not have to write this down, but I want you to note that if you are given 2 points and you're looking for an arc, so think about this very first one that says find BC, okay, that's going to mean a minor arc. We can just kind of assume that they're talking about a minor arc. If there is, if they want us to find a major arc or they want us to find a larger arc, okay, chances are they're going to give us 3 points and tell us and direct us to the way we're supposed to look at it. Okay, so for instance, if I'm looking at this and let's say I am trying to find BD, okay, BD, I'm trying to find from this point to this point. Well, if I look at that, because it's a circle, I could either address that going left or address it going right. Because I put just BD, okay, I would have just found this smaller arc here, okay, instead of going to the left. Now, if I said find BED or bed, go to bed. Nope, I would be going this other way. Okay, so unless they specify unless they specify with 3 points, you can safely assume to go the short way or find the minor arc. Okay, so this very first one says find BC. BC. I'm just going to erase this and we're going to get going. Now, remember that we still have other properties that we know, other theorems that we have been talking about. So I'm finding BC. I'm going to be finding this arc. We know this is a minor arc here, okay, which means it is going to be the same as my central angle of BFC. Well, what do I know about BFC? Okay, well, it is a vertical angle to AFE. Look at that, vertical angles. What do we know about vertical angles? They are the exact same measure. So the measure of angle BFC is 97.4. Well, we know that because it's a central angle, we have a minor arc. The minor arc is equal to that central angle. So the measure of BC, arc BC, is equal to 97.4 degrees. And they are, as an arc, they are put in degrees. Degrees. Okay? Sweet. Okay, next one is measure of BCD. Now, you could see this. I did write down which way I want you to look at it. BCD. Okay, I could have just said BD, which I crossed out there, as you can see. But they would have been the exact same thing. We're finding that smaller one. Now, BCD. We know that BC is 97.4. We know that ED is 52 degrees. How could I use those two pieces of information to help me find this CD? Because that's what I'm missing. In order for me to find this BD, I would need to find CD. Okay, so if I look at that, I would have to take 180 minus 52 minus 97.4. Now, why would I take 180? Yeah, if you look at BE, that is a semicircle. That diameter cuts it right in half, right? Well, if I know 2 out of the 3 sections, I can safely assume that if I take 180 minus 52 minus 97.4, I will find my number. Okay, so what is the measure of CD? It is going to be 30.6. Well, if I'm at 30.6, not CD, okay, I am going to 30.6 just take, remember our addition postulate, arc addition postulate, I just take BC plus CD and I get BCD. Oh my goodness, look at that. So if I take 97.4 plus 30.6, I will get BCD, which is going to be 128 degrees. Okay, again, I need my degree symbol. All right? All right, let's check it out. Okay, so we are now going to try the next. Here we go. What I want you to find is I want you to find JK, arc JK, and arc LJN. And no, I am not just kidding. I know you were trying to figure that out, or you probably might have just thought I was just kidding because of that arc. No. Okay, so I want you to try this one. Give it a shot. Good luck. Hey, go. All right, so the arc of JK. Well, same idea. We look, notice we know this angle right here, 25 degrees, because we're finding the minor arc of JK, because that's what it tells us right there. Find JK. It is going to be 25 degrees because of our vertical angles postulate. All right? All right. Next one is going to be a little bit different. We are going to be finding LJN. Well, what in the world? LJN. That's this huge angle right, or this huge arc right here. We wanted to go that way. We wanted to connect it. Notice it's LJN instead of NLJ, which would have given us two completely different arcs. Or sorry, LNJ. We have our starting point, and it goes right in order, just like an angle, LJN. So we're going to be finding this red arc. Okay, so here we go. we would take, well, I know, tricky part is, I know this entire section. What's that entire section? 65 degrees. Well, if I know that small section, I know this minor arc, I can figure out my major arc. I just take 360 and I subtract 65. If I take 360 minus 65, I get 295 degrees. Because the circle is 360 degrees, I know that my major arc plus my minor arc equals 360 degrees. All I do is subtract my minor arc from 360, and I get my major arc. Sweet! Next. So I want you to write this one. Here's a formula you do need to know. Please write all of that down. We're talking about the arc length now. So pause now. Okay, so that arc length is the distance along an arc measured in linear units. Linear units. All right. So if we're talking about minor arcs and major arcs, those are going to be measured in degrees. Okay. However, when you focus on the arc length, okay, and the central angle, the arc length is going to be in units. So meters, inches, feet, so on and so forth. Okay? So write that down. Make sure you know that formula. This M right here stands for that the degree of your arc. Okay? So if your degree of your arc was, let's say, 26 degrees, okay, that M would be your 26 degrees. Whatever that arc length, based on that central angle here, that's what that's going to be. All right? Let's try one. So when we look at this, we are going to be finding the arc length, and we're going to find it in terms of two different things. We're going to find it in terms of pi and rounded to the nearest hundredth. Okay, so now we are given two pieces of information, okay, and we are going to be finding arc FG. Now, think about it. Which way am I going to be talking about? Am I going to be looking at FG here, or am I going to be looking at FG on that length, that long one? Well, because we can safely assume that when I go from one point to the next, it's talking about minor length, so I'll be talking about this blue line here, that FG. Okay, so if I look at this, now I know a few pieces of information, but most importantly, I know my formula. My formula is going to be L is equal to 2 pi r times m over 360. Okay, where r is my radius, m is that measurement of the arc, okay, in degrees. So if I look at this, this is going to be, my answer is 2 pi r, which is 8, times m, which is 134, over 360. Now, when I look at this, okay, I'm going to be multiplying straight across, okay, and I want to use terms of pi and terms of decimals. So when I do this, I take 2 times 8 times 135 divided by 360, and I get 5.96 pi centimeters. Okay, and yes, you can put not 5.96 pi centimeters. I'm using centimeters because I'm talking about centimeters on my radius, and I'm going to be using linear units for that arc length. Now, I'm going to take 5.96 and I'm going to multiply that by pi. I get about, don't forget your symbol for about, and I get 18.71 centimeters. Okay, the very first thing is I multiplied straight across to get in terms of pi, just didn't multiply by pi. Then afterwards, I multiplied my 5.96 times pi. Okay, awesome. Here we go. Okay, so now what I want you to do is, given that information that we talked about before, given that formula, I want you to find the arc length of this one, and I want you to give your answers in terms of pi and in terms of decimals, so nearest hundredth. So give this one a shot, see what you come up with. Find GH, arc, GH. All right, so we know the solution, or sorry, not the solution, the formula for this is going to be L is equal to 2 pi r times m over 360. Okay, and when we do that, we plug in what we know. Well, we know what my r is, which is 6. We know what my measure of my arc length is. It's 40 degrees over 360. Okay, from here, if you look at this slide, you multiply all of these across, you would get 1.3 repeating. Okay, can we put 1.3 repeating without using that line? Yes, we could. We could simplify that down to 4/3 pi, and that would work. Okay, if you put 1.3 repeating, that's fine. Okay, I would then take 4/3 pi, and I would have a answer of meters as my linear units. Then I take 4/3 over 1.3 repeating and multiply that by pi, and I get 4.19 meters. Okay, so the very first thing is I get it in terms of pi. I do not multiply. I just take 2 times 6 times 40 divided by 360, which I got 1.3 repeating, which you may have also had this. Okay, that would be in terms of pi. Then I multiplied that to get about 4.19. All right, awesome. Make sure when you do this, make sure that you put in your linear units. You do need a label, but other than that, we're set to go. Just memorize that formula. Gosh, don't you just love memorizing formulas? I know you do. After the surface area chapter, after volumes, you gotta love it. All right, here we go. We're done for today. Your assignment you will get tomorrow. Have a wonderful day. I'll see you later. Bye.